I think we've all been there. You're watching a crucial page take, I don't know, 4 agonizing seconds to load, and it kills your flow.
It's so frustrating. But what's fascinating is the invisible engineering that goes into making things feel instant.
Exactly. And that's what we're doing today. We are pulling back the curtain on that invisible speed, using the work of two legends, Jeff Dean and Sanjay Ghemawat, as our guide.
Right. We're looking at their performance hints document. And it really gets to the heart of what Donald Knuth meant when he talked about optimization.
Ah, the famous quote. Everyone says, premature optimization is the root of all evil.
They do, but they forget the second half. Knuth said, yet we should not pass up our opportunities in that critical 3%. This deep dive is about finding that 3%.
And that's where the magic happens. Okay, so where do we even start? What's the strategy?
Well, the first big lesson is that it all starts with estimation, not, guesswork, but really developing an intuition for the cost of different operations.
You mean like knowing how long something should take?
Exactly. The latency hierarchy is the perfect example. It's a way to visualize those costs. An L1 cache reference is incredibly fast. It's our baseline.
Okay, so just how fast are we talking? What's the scale of the difference between that and, say, a network call?
The difference is just immense. I mean,
Yeah.
it basically dictates your entire system architecture. If an L1 cache reference is half a nanosecond,
Okay.
a network round trip, even inside the same data center, is 50,000 nanoseconds.
Whoa, that's a lot.
It's like this.
Oh,
If grabbing data from the cache is like taking one step, that network call is like driving 100 miles. When you see that cost, you design your whole system differently.
I see. So estimation forces you to make smart design choices from the start. But where do the really massive performance wins come from?
They come from the math, from the
Yeah.
foundation. We're talking about algorithmic improvement.
Right, like moving from ON log n to ON. For anyone listening, what does that shift actually, feel like in practice?
It's the difference between work that explodes versus work that's manageable. ON means if your data doubles, your work doubles. Simple. ON log n means when your data doubles, the work more than doubles. It gets exponentially harder. One example they gave was replacing a sorted list intersection, that's ON log n, with a simple hash table lookup, which is ON.
And the result?
A 21.6% improvement in a massive compilation benchmark, just from that one decision.
That's incredible. Okay, so that's the big picture. What about the tactical side? What happens when you run a profile and there's no obvious bottleneck? Everything looks flat.
Yeah, that's a common challenge, and that's where the small, precise optimizations add up. The big one is avoiding repetitive work, especially inside loops. The key technique is to hoist temporary objects.
Hoisting. Break that down for us.
It's simple, really. It just means you prepare your tools before you start the job. Instead of creating a new data container, like a protobuf variable, every single time you go through a loop.
You create it once, outside the loop.
Exactly. You define it once, and then you just reuse its allocated storage on each iteration. You avoid all those expensive creation and destruction costs over and over again.
Reusing memory instead of constantly throwing it away. That level of precision thinking, it's so key. And that applies to any complex challenge, not just low-level code.
Absolutely.
This deep dive is brought to you by Silk. If you're tackling big challenges in your business, maybe with complex AI training, automation, or software integration, you need experts who get these deep principles of efficiency. To find out where AI agents could make the biggest impact for you, check out embersilk.com.
You know, that idea of precision brings up another key tactic, which is creating fast paths for common cases.
Right, so optimize for what happens 99% of the time.
Yes. Don't let the rare, complicated edge case slow everything down. A great example from the source was a web server optimization. They used to pre-allocate 200 nodes to handle any possible query.
But most queries don't need that many.
Almost none of them. So they changed it to pre-allocate only 10 nodes. Just 10. And that one change led to a 7.5% reduction in CPU usage across the whole server fleet.
Because they streamlined the default path and only did the extra work when it was absolutely necessary. It's a lesson in, engineering discipline.
It really is. It shows that performance tuning is both an art and a science. It's that strategic foresight with algorithms.
Combined with that tactical precision in how you manage memory, these principles aren't just for Google scale, they're universal.
And they show that optimization isn't about compromise. It's about unlocking future capability.
I love that. Dean and Ghemawat's work proves that if a smart decision about a data structure can give you a 3.3 times performance boost, think about what incredible new scale or efficiency your critical 3% could unlock next. That's the real potential here. That's all for this deep dive. If you enjoyed this show, please subscribe. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.